you find the power for a three-phase circuit, always find the line values for voltage as well as current. Now next example. Three currents are represented by I1, which is equal to 10 sin omega t, I2, which is equal to 20 sin omega t minus pi by 6, and I3, which is equal to 30 sin omega t plus pi by 4. Find the magnitude and phase angle of resultant current. This example was asked in December 2008 and January 2009 also. So now this example is based on a vector representation of alternating quantity. So if you are satisfied three conditions, you can represent any alternating quantity by a vector. So first equation I1, which is equal to 10 sin omega t, it will indicate that the magnitude of this particular current is 10 and the phase angle for this particular current is 0. For I2, your magnitude is 20 and your phase angle is minus pi by 6. It will indicate it is a lagging. And for I3, it is 30 is the magnitude and the phase angle is plus pi by 4. So it will indicate it is leading. So first of all, represent this alternating quantity by a vector. As shown in figure, OA will indicate the first quantity. Means the magnitude of this OA is equal to 10 and the phase angle is 0. So this is our reference axis, x dash is our reference axis. So this OA is placed on this axis. It will indicate the phase angle between reference axis and OA is equal to 0. So this is the representation of first quantity I1, which is represented by OA. Phase angle is 0, magnitude is 10. Now for second quantity I2, magnitude is 20 and phase angle is minus pi by 6. So OB, this is our OB, which will indicate the magnitude is equal to 20 and phase angle is minus pi by 6. It will indicate that it is a lagging by 30 degree. So the angle is 30, magnitude is 20. So this will represent the I2 quantity. Now for I3, magnitude is 30 and phase angle is plus pi by 4. So here it is OC, magnitude is 30 and the angle is plus 45. So this is the representation of alternating quantity by a vector quantity. So OA is equal to 10 having 0 phase angle, OB is equal to 20 lagging by a 30 degree, and OC is equal to 30 leading by a 45 degree. So this is just a representation of alternating quantity by a vector. Now we are finding the resultant of a given quantity. So for that you have to find the x component and y component, or you can say horizontal component and vertical component for a given quantities. Okay, first of all we are finding the x component. So x component is nothing but the cos component of a given quantity. So it is equal to OA cos 0 because the phase angle is 0 plus OB cos 30 plus OC cos 45. So cos 0 is 1. So OA cos 0 is equal to 10 plus 20 cos 30 plus 30 cos 45. If you are put the values of cos 30 and cos 45, your final answer is 48.53. This is the x component for a three alternating quantities. Same way we are finding the y component for all the three given quantities. So y component is the sine component of a given quantity. So first is OA sine 0 plus minus OB sine 30, because it is a minus pi by 6, or you can say lagging. So here it is minus OB sine 30 plus OC sine 45. Now sine 0 is equal to 0. So your y component for a first current I1 is equal to 0. Now for second current it is minus 20 sine 30 plus 30 sine 45. So it is equal to minus 10 plus 21.21. So your final answer for a y component is 11.213. So x component and y component for a given quantity is already known. Now you can find the magnitude for a resultant. So magnitude of a resultant is equal to x component square plus y component square, under root of x component square plus y component square. So it is equal to under root of 48.53 square plus 11.21 square. So your final answer for a magnitude is 49.81. Now you have to find the phase angle for a given resultant. So equation for a phase angle is also known to you. Phase angle is denoted by tan phi, or you can say denoted by phi. So tan phi is equal to y component divided by x component. So it is equal to 11.21 divided by 48.53. So your answer is 0.231 radian. Convert it into degree. You can easily convert any radian quantity to the degree. Use the equation which is multiply by pi by 180 or 180 by pi to convert degree to radian or radian to degree. So convert it into degree. So it is 13 degree. So your resultant current IR is equal to 49.81 sine omega t plus 13. Okay, so 49.81 is the magnitude of resultant quantity and 13 is the phase angle of a resultant quantity. So whenever you find a resultant for a given quantities, first of all you have to find the x component of a given quantity and find the y component of given quantity, then find the phase angle of a given quantity. So the actual value of resultant is known to you in terms of magnitude as well as in terms of phase angle also, and write down in a form of equation which is the combination of magnitude and phase angle both. Now next example, a certain waveform has a form factor of 1.2 and a peak factor of 1.5. If the maximum value is 100, find the RMS value and average value. This was asked in December 2008. Now values of form factor and peak factor is given to you and maximum value is also given to you. You have to find the RMS value and average value. So in this example you have to use the equations of form factor and peak factor. Now value of form factor and peak factor is constant for each and every alternating quantity. So form factor is equal to 1.2 and peak factor is equal to 1.5. So KF is equal to, means form factor is equal to IRMS divided by I average and peak factor is equal to IM, means maximum value, divided by IRMS. Now values of form factor and peak factor is given to you. Use this relation and you can easily find the values of a current. So it is equal to 1.5, which is your peak factor, is equal to IM divided by IRMS is equal to 100 divided by IRMS. So your value of RMS current is 16.66. Similarly, if you are use the relation for a form factor, so it is 1.2, which is equal to IRMS divided by I average. So your value of average current is 55.55 ampere. So if the relationship for a form factor and peak factor is known to you and any one value of a current is given to you, you can easily find the other values for a given current. Okay, now next example. 3 similar coils, each of resistance 28 ohm and inductance 0.7 Henry are connected in star and delta if the supply voltage is 230 volt 50 Hz. Calculate the line current and total power absorbed by the given circuit. This was asked in 2008 and 2009 also. Now the value of resistance per phase is given, it is 28 ohm. Inductive reactance XL, which is equal to 2 pi FL. Value of frequency and inductor is given. So your value of XL is 219.8 ohm. Now you have to find the impedance for a given circuit, which is ZPH, Z per phase, is equal to under root of R phase square plus XL square. Now values of resistance per phase and inductive reactance are given in the data. So you can use this value and find the value of impedance per phase, which is equal to under root of 28 square plus 219.8 square, which is equal to 221.57 ohm. Now power factor of the load is R phase divided by Z phase. So put the values of resistance and impedance. So your power factor is 0.126 lagging. It will indicate it is an inductive circuit. Now same way you can find the values for star connections. Star connection phase voltage is equal to VL divided by root 3. So it is equal to 132.8. This is about voltage. Now if you have to find the current for a star connection, so as we know in star connection, line current and phase current both are same, then use this relation. So it is equal to IL is equal to I phase, which is equal to V phase divided by Z phase. Put the values and your answer for a current is 0.6 ampere. So the power absorbed by this particular circuit is root 3 into VL IL cos phi. Put the values of line current and line voltage, 230 into 0.6 into 0.1264. So it is 3021 watt. This is the power absorbed by a particular circuit when it is connected in star. Now if it is connected in delta, then as we know phase voltage and line voltage for a delta connection is same. So V phase is equal to VL is equal to 230 volt. So your I phase is equal to V phase divided by Z phase. So it is equal to 1.038 ampere. And your line current is equal to root 3 into I phase. So it is equal to 1.8 ampere. So your power absorbed by this particular circuit is root 3 VL IL cos phi. So which is equal to 90.63 watt. So whenever the circuits are connected in star or in delta, use the relationship for voltage and current and accordingly find the magnitude of power, root 3 VL IL cos phi. So today we will stop our session over here. In next session we will solve some more example from GTU question paper. Thank you.